And then the 2019 and the 2020 Safety and Integrity Alliance Code of Standards was part of them, was integrated into the HISA regulations, became the HISA regulations with some changes because it's all kind of this evolving. So, okay, so the maintenance quality system, the current priorities and best practice, and the idea of the maintenance quality system, there were only about 16 tracks, 14 to 16 tracks that were participating in that, and with HISA, that had become much more universal. The other priorities, and we talked a little bit about this earlier, the idea on this was to look at some of these other things that we talked about this morning. Now you can do that. Okay, so what the idea of the maintenance quality system was that it was going to be paperwork and more like an ISO process, not dictating, not a design criteria, not dictating what you were doing, but asking what you were going to do on your maintenance and then helping set expectations on documenting what's being done. Very much consistent with a more of a regulatory role. Data then is available, and this gets back to the epidemiological work that Sue and some other people have done that has been so important. So there's an old Bill Crosby used to say quality is free. The idea on this is that if you meet regulations and are consistent, it actually doesn't cost you money, it saves you money because what you're doing is you're maintaining a surface and you're meeting the requirements constantly. So the idea is to make sure folks are doing their job, provide information aid for decisions, and the three questions are: what are you planning to do? Did you do what you planned? And did you check your work? Grading is a classic case of that. We grade every Wednesday. That's the schedule. Did you grade last Wednesday? And then did you check your work? Did you go out with a laser and check your work? And that should normally be done independently of the person who's doing that. And that process applies to every one of these things, including material additions. FDA does this for drug trials. FAA does this for aircraft, although with the 737 MAX, that may not be the best example, but they're not, the FAA never tells Boeing how often to do a maintenance procedure. They ask Boeing when the maintenance procedure is going to be done and how they're going to document it, what the process is. So the first stage of this is the design, documentation, and setup, and this is the biggest question we start out with is what is the equipment you're using on the track? It can vary from track to track. The names of the equipment varies from track to track. And this allows us to set up the database and the documentation for the whole process. Next thing, we're over at the lab, the target composition. What's exciting about the HISA regulations at this point, we've got target compositions for, I think we can say just about every track in the United States. And we got a couple missing, one Mountaineer still needs to be filled in, and a couple others, but we've got target composition. After only 1 year, we've already got this really crucial piece of information, because then if there's a problem, we can go back and look at that baseline and compare to it. The geometry, this is less sophisticated at this point because we're just looking at crossfalls at the poles. Longer term, we have to improve what we're doing and understand the transitions into the turbines. And then the weather station, which you saw the weather station sitting over at RSTL. And we've got a number of those at the different tracks. The other tracks that don't have a weather station use a hyperlocal algorithm, where what they do is they essentially interpolate between a number of different weather stations and estimate the weather at that location. We maintain the hyperlocal data sets at the same time we have weather stations there, because if we have a problem with rain gauge or something, that allows us to fill in and not have gaps. So this whole process has to take place for the dirt, turf, and synthetic, with a number of differences between, and for example, the drainage plan is the same for the dirt to synthetic. Turf calendar is something that would look at what is your typical protocol that you have for different for aeration, how often is it typically aerated and things. So I always like to look at this as the flight certification, the initial process like you would with the FAA. One of the things we found in the initial visits, and this slide goes back 10 years, is we found that the transitions in the curves were quite different on the East Coast and the West Coast. West Coast, or when they put in the synthetic tracks, even on the West Coast, some of the tracks didn't hit their full banking until they hit the middle of the curve. It would only then completely transition as they go back. That's very different than the standard for New York and California, where about 100 meters before the start of the turn, the transition would start into the banking. It would be at full banking a quarter or a third of the way through and maintain the full banking through that whole middle half or 2/3 of the turn. And then the consistent equipment names. Conditioner on the West Coast looks an awful lot like a roller harrow on the West Coast, and those names. So as we built up the relational database, we had a canonical name that was used for the local people to enter it. Then we had a reference name that we could use so we could compare what they were doing at the different tracks with the different pieces of equipment. The next stage of this, the second stage, is the race meter seasonal test. At this point, we're beginning to do this, and this is what's probably been the biggest success with the funding from the Jockey Club for the equipment and the support from HISA to schedule these. The race meter seasonal tests are just happening. This is the ground penetrating radar, the biomechanical surface testing, the test composition for 7 standard locations. And again, there's a process for each of the dirt, turf, and synthetic with the characterization. So this is happening, this is going, you know, to say we've got full compliance, I think we're pretty close. You know, the ones we're missing are we missed one of the California fairs, 2 of the fairs, you know, it's that level where this is going well. And I always say this looks more like the pre-flight inspection. We try to get this, we try to do this early enough that if we find anything, it can just be fixed. So this is the classic case where the hard pan hasn't been established and we just fix it. The OBST's testing started in discussions in 1998. By 2004, we were testing tracks, and this is what you saw, and you've seen this probably before. But by 2016, we already had 6,000 tests on 80 racing and training surfaces that we were looking at for dirt and synthetic. And the biggest takeaway we had back in 2016 was synthetic versus dirt. There was so much more variation on dirt. Not that there was, the grip was higher on dirt than synthetic, but in general, it was a little higher on synthetic. What was most notable was the variability. And this, I think, gets back to where we can immediately start benefiting from what we're doing, because this variability within this dirt is a huge factor in the overall experience of the horse, both shipping between surfaces as well as traveling across a certain surface. We see the same sort of a dynamic with cushioning, and with cushioning, what we see with the vertical is we also see a lot of outliers. I think one of the discussions I want to have, and I've had with Ewan, and he's had some good ideas, is how we're going to analyze this and analyze these outliers, because this is the proverbial bad step, is the way I like to think about these, and we should absolutely be eliminating those outliers that are sitting there. And what's really noticeable is the dirt outliers really stand out on that. But again, you see the thing where it's overlapping and the variability is the big difference between dirt and synthetic. This is basically the hypothesis we've been basing all of our work we've been doing for this time on, is that the safety of synthetic is probably has as much to do with that reduced variability on synthetic as it does any particular value. That doesn't say that the synthetic is biomechanically desirable necessarily, but it's at least adaptable, because the horse is necessarily going to be able to adapt from between surfaces, but not necessarily stripe to stripe. This is one from the ground penetrating radar that you saw this morning. This is a track that had a severe rail bias. This is the ground penetrating radar. This is the rail. This is going across it. Now, it's actually got a cushion that looks pretty consistent, but the material underneath it changed dramatically as you went out from the rail. So it was significantly faster along the rail than it was out in path 3 or path 5. So this is the kind of thing where if you see something like this and you tell it, this can be fixed. This actually was fixed just with a conditioner. It was by just taking it, making sure that it cut into that and repairing that. This is again these sorts of consistency issues that you see that I think are probably very important. As I mentioned, the big factor on this pre-meet inspection was the Jockey Club gift that allowed us to build up the infrastructure. Prior to the Jockey Club gift, we had exactly one system that we traveled back and forth, and Caleb took how many trips? 5 trips to the West Coast in 2019 from Lexington to do the Santa Anita testing. So
It happened for me.
oh, I'm sorry. I'm sorry. Credit where credit's due. Yeah. All right, this is the hardest part, and this is going to be a lot of the focus of what I want to talk about in the next few days. We have the pre-meet inspection where we can say, in theory, if everything's right, here's what we have, and we can control it. The real question is, what factors change on a shorter time horizon than the big factors? So the composition of the track is unlikely to change over the course of day to day, but moisture will change, grading will change, moisture is a big one. moisture. On the daily tracking, we track every piece of equipment that goes out on the track. The way this is done right now is it's just manual data entry. Cushion measurements are being made at several of the tracks, but this is probably the lowest compliance of anything. We make moisture measurements. A number of the tracks do a very good job on that, and they're not necessarily, Fairgrounds has done a perfect job for 10 years. I mean, it has to do with the commitment of the superintendent there. And this is all then put in place and documented. All of this this is the most difficult, is daily tracking and measurements. And in a perfect world, this is where we get back to what the Track Surface Advisory Group really needs in front of them, is the black box. The dashboard or the black box, the dashboard for the superintendent that day, the black box, if there's a problem and there's a cluster of injuries, we need to be able to go back and see this data. Most basic data we have, and Joe was talking about, the track drying out being higher risk than the track being wet. This is the sort of information where just really good weather data and ideally moisture data on the track, we can begin to see that drying process and see if that's going to be associated with clusters of injuries. Maintaining a wet track, draining a turf track. This is the sort of pattern that you see where it'll be wet, manage to dry it out, wet, rained again. These sorts of patterns are not at all unusual on the track. There's no way that can be a desirable behavior for the track. That was actually a turf track there. And then irrigating and using the water trucks. The other thing that we have is we've got different maintenance practices. We have a lot of this on the synthetic tracks where they would use the power harrow at some tracks, they use the cultivator at other tracks, they use the rototiller at other tracks. Looking at what that does, they do fundamentally different things to the surfaces. And until relatively recently, even the manufacturers would just give kind of an outline and then say, use your own judgment at that point. And some of them did a terrific job and some of them didn't do as good a job. And then, as I mentioned, just the human resources to go and measure the tracks. It's not, it doesn't necessarily map who's going to commit the resources. Erroneous in Uruguay, they, at least under their old management, right, used to carefully monitor all of this on a daily basis. Oakland did a really good job, and then they had somebody move on, and you lose the person. So This is where the automation is needed, and some of that fits. Turf courses, I think, needs to be a huge focus. There's a lot of pressure on use of turf courses. There's large fields, big handle, and what happens is there's pressure to continue to use them when they shouldn't be used and keep the horses on it. Divot repair, there's some tracks that don't even repair their divots over the course of the race meet. When the divot material is used, it's usually inappropriate for the material, and so this is something that I've talked to people outside of the US, where this isn't just in the US, they repair divots and then they just use sand. It's a native soil track and it makes no sense whatsoever. And then also address major wear areas and starting gate locations, especially in the more confined tracks, you know, fairgrounds or a track that's narrower with only a couple starting positions. That wear area can be a huge challenge. And this is Alejandra and Peter, who are both working on the PhD related to this. And then consistent measurements. Some of the people who are going to talk today are going to talk about how different measurements are being used in different countries. Most of these are not international standards of any kind. They're just a company, a vendor who came up with a tool. Some of it's been validated, some of it hasn't been validated. It needs to be based on international standards, and there needs to be published literature to support the use of it. And these are some of the standards that we've worked with to develop. ASTM has a lot of problems, and it's a consensus-based process. I would love to talk about in the next couple of days what we can do to move forward and just go ahead and standardize some of these test methods with or without ASTM. So we don't have the black box. The database functions are being rebuilt by Jockey Club or are rebuilt by the Jockey Club, but that's the front end piece. We've still got quite a bit of infrastructure that's needed, but the biggest challenge right now is for that daily data because the data quality is mediocre. So as soon as we've got something we need to get to the track surfaces advisory room, we say it's almost guaranteed that that'll be a gap in the data. They were busy, things weren't going well, and so what was the first thing to do? Documenting the maintenance. And then the key to this is the more complete data set can be linked to the EID and then also the HISA data, because the more complete we have this data, because the catastrophic injury is a rare event, we need a very, very complete and high quality data set. So, Code of Standards. Code of Standards for the Safety and Integrity Alliance in 2019 required electronic records for maintenance and track testing. This was specifically to address when there was a cluster of injuries. You could go back and look at it. This was driven originally by the cluster of injuries at Aqueduct in what year?
2011.
2011. And at that point, there were cushion depth measurements for all the NTRA tracks in file drawers on 11 by 14 pieces of paper folded in a drawer. That was the start of the electronic records. It was NTRA that got the original maintenance quality system database. That's also where the Code of Standards ended up with that. The old 2019 Code of Standards had moisture, cushion depth, and going stick required, and composition at least once a year. I can tell you that about half, well, less than half, I don't know, about half the accredited tracks complied with the Code of Standards. They were all accredited, but about half of them actually did what was required. In 2020, it became much more stringent, and it was never really completely published, even though I was told I could include it. And this is the racing committee. Jim Pendergast was the chair of that. And this was much closer to the MQS with the 3-phase process with the documentation for the design and all of that. And the composition testing then was very similar to the Safety and Integrity Alliance Code of Standards. All right, so where are we now? Oops, there we go. Skip. So for HISA, we've got a similar structure to the MQS. The sampling, the spatial sampling frequency is lower than it was on the Safety and Integrity Alliance. It ended up being just 4 holes in 2 locations required. The amount of sampling is required is reduced, and the composition testing then is very similar to the 2019 Safety Integrity Alliance Code of Standards. And eventually, I hope we'll be able to close these gaps and get them closer. Where we're at with the HISA regulations, the design documentation, those mechanical, all those, we've got good baseline composition data for all the tracks we've tested. We have very basic design information on the tracks. And if and the pre-meet inspection is great. The one weakness then is the daily data, where I believe right now we are getting less daily data than we were 2 or 3 years ago. And that was partly because of the new database. There was resistance to the new database. We had problems with some of our automated tools that we had set up, that they became obsolete. And so we really made tremendous progress on 2, decent progress on 1, and if anything, we've gotten worse on 3. Let me be clear, it's not complicated. What we're asking is, after training, we do soil moisture and cushion depth, with emphasis on soil moisture and midge cushion depth. It's not the end of the world. Track maintenance documented during racing, and then this is all just manually entered. So that's the expectation of the daily record keeping. On turf tracks, it's soil moisture, it's either going stick or the long champ penetrometer, and then track maintenance, and especially top dressing and aeration are the 2 that I understand the best. So here's what I got goals for the meeting. Ensure everybody understands the current measurements pre-meet and daily. Caleb's going to go over some of that. We're going to talk about some of that. We're also going to tie it back to what's being done for FEI, for the big events, for the 4 to 5 star events. Agree on some of these biomechanically sound measurements for the pre-meet inspection. This is stuff that we've had a lot of discussion with Lars and Sue and Caleb, and the whole come out with how we're going to do these calculations and making sure that we're getting the right ones. And as Joe asked, we're saving all of the original data. We can always reprocess it, but we're going to try and at least get everything we can in one form for now. Allow some international norms to allow data to be compared between jurisdictions. One of the things we've added on is because Allison and Sarah have been using the Vienna ball for their eventing and British horse racing tests, we're going to add that on. We purchased one. We're going to add that on to our pre-meet inspection for turf tracks, so we tie that in. So all of them, and at that point, this is a big success. At that point, we then put this with the eventing and BHA turf track studies, and suddenly our data set gets so much bigger and is so much more useful, so much quicker. And the penetrometer, Chris Rogers has talked about, we just got 15 years of data from every track in New Zealand. That's fantastic, because then we can take that again on our turf tracks and begin to look where that goes. And then look at how we can format this in such a way to make work like Peter Hitchens and Ewan Bennett's easier from an epidemiological standpoint, because then they can just fold them into the existing models. So that's my goal. This is really a slide I left in here just because this is whenever I talk to superintendents or anybody at the racetrack, what's key on this is, I think it's going to be really important that we not talk about defining how we do it, but understanding what's being done at this point, and then finding best practices. I think the Track Surfaces Advisory Group has done a good job of beginning to communicate that. But defining the materials, geometry, and maintenance, and then measure and implement. Again, thinking the role here is more like the FAA, where you're going to document it. I think it's going to lead us longer term to understanding what are high risk, especially things like when you put down the back brake on a drying track. But those are the things that we want data to be able to understand what's doing it, instead of just speculating. So that's all I have.